All right, let's go ahead and start. Okay, so I was originally going to start in a new section, but I figured let's get a review before Mr. Mrozinski gives his test tomorrow. So this will just be a review over Chapter 2 stuff. I'm going to try to hit a little bit from each section of Chapter 2. So let's just go right on into it. So remember that we said that there's a difference between equations and expressions. And expressions are where we have just a single idea. So 7 times 3y minus 7. This would be a single idea. This would be just an expression. If we knew what we could put in for y, we would get a value out. That's the idea. Now, if we add to this equals negative 22 times 3 minus y, now we have an equation because we're not just using a single idea, we're comparing two ideas. We're comparing 7 times 3y minus 7 and negative 22 times 3 minus y. And the comparison between these two is represented by the equal signs. Those equal signs say that these are exactly equal. They are in perfect balance with each other. And so what we can do now is instead of just having to kind of say, well, I don't know, we can plug things in for y, we can actually solve and get a value for y that makes this comparison true. So some number out there is going to be able to be plugged in for y to make both of these equal to each other. Okay, so if we want to do that, what we are going to need to do to solve this is first say we need to simplify each of these expressions as much as we possibly can. So, like on this side and this side, we can distribute this number into the parentheses, and that will unlock the parentheses for us. We won't have anything on the outside of the parentheses. Keep them closed. We'll have access to the numbers on the inside. Same thing over here. Negative 22, we're going to distribute that into the parentheses so that we actually have access to the numbers inside of here. Okay, so 7 times 3y is going to give us 21y. And then 7 times negative 7 is negative 49. And that's equal to, same thing on this side, distribute the 22. So negative 22 times 3 is going to be negative 66. And then negative 22 times negative y is going to be positive 22y. All right. So now, both of these expressions, the ones on each side, are simplified. And now that they are simplified, we can go ahead and start moving things around until we get y by itself. So we have a y on each side. We need to choose which side we want the y on. I'm going to take 22y to this side. So to do that, I'm going to need to cancel it out on this side first. So the opposite of adding 22y would be subtracting 22y. And I'll need to do it to this side as well to keep balance. Remember, this equal sign shows perfect balance. So I will cancel that on this side since those are opposites. On this side, 21y minus 22y is going to give us a negative y left over, a negative 1y. Okay, Now, we have this negative 49 next to our y here. Again, we want to get that y by itself, so we need to get the negative 49 away from it. So, canceling it would be adding 49. And again, we want to do that to both sides. Okay, so now all we need to do is negative 66 plus 49, and that's going to come out to be 17. So this will cancel here, leaving us with negative y. Here, we're going to get negative 17. Okay, now y is not by itself yet because this is negative y. Technically, this is negative 1 times y. So we need to do one more step here, and that is divide the negative 1 off. And we'll do that to both sides. That'll cancel there, leaving us with just y. And on this side, negative divided by negative is a positive, so that's now positive 17. So the thing that we would plug in to our original equation to make both of these sides the same thing would be 17. If we plug 17 in for y, both of these will be equal to each other. And that's the basic idea behind these solving equation things. Okay. So I'll move on. Now again, Mr. Mrozinski's exam is going to have some more complicated examples than mine did. So I actually do want to go into one of those things that you'll probably see on his exam. So we're going to have something like 8y minus 4 all over 6 plus 13 over 12 equals 16y plus 5 all over 12. And you're probably looking at this and saying, man, that looks pretty complicated. We got all these fractions in here. We got y's all over the place. Yeah, it looks pretty intimidating. Actually, this is going to be a lot easier than it looks right now. Really, the fractions are a problem to us. We could go ahead and do all of our rules for fractions and you know, add, subtract, multiply, and divide these fractions. However, instead of doing that, what we can do is we can take one step to get rid of all of the fractions in this and have a normal looking equation, something that's basically what we were just working with. Okay, so if you notice the denominators we have, 6, 12, and 12, we can easily make all of these the same denominator. And hey, if we were going to use our rules for fractions, we'd need to have common denominators to add and subtract things. So I can easily make this 6 into a 12 as well, if I just multiply it by 2. Of course, I'd need to do the same thing to the top, multiply it by 2 as well, and that will give us a common denominator of 12. And when we do this, something interesting is going to happen in this case. Let me show you what I mean. So first of all, top part here, this 2 is going to need to get distributed into here. So 2 times 8y is 16y. 2 times negative 4 is going to be negative 8. It's now over 12. And then this is still 13 over 12. And this is still 16y plus 5 all over, ooh, all over 12. Now then, let's say I wanted to get, oh shoot, I forgot the y in there. Let's say I wanted to get this y by itself. Well, the first thing I need to do is get rid of this 12. I need to take it and multiply both sides by 12. Okay, well, if I do that, multiply this side by 12, multiply this side by 12, this would cancel, yeah. And it would just leave us with 16y plus 5. However, we basically have the same thing over here. What we did on this side was multiply this thing that was being divided by 12, and it canceled. Well, these two are also being divided by 12, and now we're multiplying them by 12. Well, they're also going to cancel. So instead of having all this stuff over 12, basically all those denominators cancel, and we're left with what's on top, the numerators. So the takeaway here with this step is that if we have an equation that has fractions in it, get all of those fractions over the same denominator. Make everything have a common denominator. And once you do that, you can take out all those denominators and just have what's left on top. And now, if we look, we have a normal looking equation, something we can definitely solve. Okay, so negative 8 and 13 are going to give us 5. So we've got 16y plus 5 equals 16y plus 5. And now we can see something else that's going on here. So remember, we have three types of equations. We have conditional equations, identities, and contradictions. Well, here we have 16y plus 5 equals 16y plus 5. Those are the exact same things. It makes sense for them to be exactly equal. They are the exact same things. And if we were to continue to solve this, so like subtract 5 from both sides, that give us just 16y equals 16y. Subtract 16y from both sides, we get 0 equals 0. Which means that this is an identity. Anytime we have something exactly equal to itself, that is an identity. So the answer here would be that y is all real numbers. Doesn't really matter what we plug in for y into our original equation. It's going to work. It's going to make both sides equal to each other. Okay, so I'll pause for questions real quick. Okay, I'm not seeing any questions, so I'll move on. All right. Aside from equations, we also talked about inequalities. And so an inequality would be something like 3z minus 2 is greater than or equal to 4 plus 5z. Okay, so these work very similarly to equations. However, there is some difference, and the difference comes in with this symbol here, the greater than or equal to symbol. So this does not show balance like an equation does. This shows weight. This side has more weight than this side. Okay? So again, it's solved mostly the same way with an extra little thing that we have to keep in mind. So let's try solving this. So I want to get z by itself. I'm going to go ahead and take 5z and bring it over here. So cancel it out on this side. Subtract 5z. And do the same thing to this side. So subtract 5z. Cancels. Over here, we're going to get negative 2z. Then we have minus 2 is greater than or equal to 4. Alright. So now, we need to get this z by itself, so we need to take this negative 2 to the other side. So plus 2. That cancels there, leaving us with negative 2z is greater than or equal to 6. And now we need to get the negative 2 off of z. However, remember, what we're about to do is divide both sides by a negative. So we're dividing both sides by negative 2. When we multiply or divide both sides by a negative number, that is going to flip all of the signs of both sides. And because of that, that means that our weight is also going to flip. So yeah, this cancels, leaving us with z. And this is going to give us negative 3. But because our weight has changed, we need to flip our inequality here, and instead of it being greater than or equal to, it's going to be less than or equal to. So our answer here is that z must be less than or equal to negative 3. Okay. Now, having that answer is good, but it's also useful to know what this answer looks like. And so for that, we graph it. So 0 in the middle, negatives on this side, positives on this side. So we need to put a point on negative 3. I'm going to say negative 3 is about here. And our point tells us whether we are going to be equal to that or not, whether we can be equal to negative 3 or not. So this says we can be equal to. This says less than or equal to. So equal to is a closed dot. Remember, if we don't have that line there, if it's just less than, then it's an open circle. Okay. Then we need to put an arrow showing where z can be. Well, z is everything less than negative 3. So z is everything on this side of -3. And there's our graph. And graphs are nice. They easily show us what our solution set looks like. Again, this one's saying, okay, everything smaller than 3 is what our answer could be. However, they are kind of large and cumbersome, so we also have interval notation that we could put our answer in. And interval notation is just a nice, quick way to look at a solution set and understand what our answers look like. If we divide a positive number, would the sign remain the same? Remember that if we multiply or divide something by a negative, doesn't matter what that original thing is, it's going to change its sign. So if we multiply a negative times a negative, we get a positive. If we multiply a positive times a positive, still a positive. If you multiply a negative times a positive, it's a negative. So it doesn't matter if we multiply both sides by a negative number, what that original number was, it's going to change its sign. So like what we have here, -2z, divide by that -2, we get a positive. It changed its sign. It started out as a negative, it's now positive. Then over on this side we have +6 divided by -2. It's now a negative. I wouldn't worry so much about the signs of things so much as if you divide both sides by a negative or multiply both sides by a negative, your sign is going to flip. Your inequality is going to flip. So like we started out with a greater than symbol here. Now we have a less than because we divided both sides by a negative. So if we divide by a positive number, nothing's going to change. It's not going to do anything interesting. It's just going to be the same kind of inequality. If we divide or multiply by a negative number, that's when things start changing. I hope that answers your question. Okay, so let's go ahead and look at the interval notation. So interval notation has a start point and an end point. And we read those start points and end points from left to right. So this thing, again, it's going all the way over here off our page. And that's starting at -infinity. And then it goes from -infinity all the way over here to the right, and then stops at -3. So our start point is -infinity, our end point is -3. Now we need to say whether we can be equal to these points or not. Well, infinity we can never be equal to, so we will use a parenthesis to show that we can't be equal to that. -3, hey, actually it has that closed dot and we have the equal to symbol on our inequality. So that says that we can be equal to -3. So we will close that up with a bracket. Again, remember, the line underneath our inequality, a closed dot, a bracket, those all mean the same thing. They mean that we can be equal to. Okay. So let's try another one of these things. Again, a harder example. So something you might encounter on Mr. Mrozinski's exam is compound inequalities. Now, we did go over compound inequalities a little bit in my previous lectures. However, this is a different way of seeing them. So something like, come on, negative 13 is less than 4y minus 5. And 4y minus 5 is less than or equal to 31. All right. So here we have not just one, but two inequality symbols. And the reason why is because what's basically gone on here is someone has stuck together two of these inequalities. Okay? So they're saying that it's not just that we're comparing it to negative 13, but we're also comparing it to 31. So what you want to do here is break this up back into the two separate inequalities. One where we have negative 13 is less than 4y minus 5. And one where we have 4y minus 5 is less than or equal to 31. Okay, so let me get some stuff here. Change this to something like that, okay. There we go. Oh, shit. My fill color is red. And fill color should be that. Okay, so this one went here. And then this one went here. Okay, just to hopefully clear that up. And now we solve each of these separately. Okay, so again, we want to get y by itself here. So what we need to do is get the 5 over here. So I'm going to add 5. So negative 13 plus 5 is going to give us 8. On this side just cancels, and we're left with 8 is less than 4y. And then we need to, oh shoot, that should be negative 8. Then we need to divide both sides by 4. That cancels there. And because this is a positive number that we divided by, we don't need to worry about flipping that inequality. It's only negatives that we need to worry about when we divide or multiply both sides by negatives. So this is going to be negative 2 is less than y. So there's one of our solutions. Over here, we need to do the same thing, solve for y. So add 5 to both sides. And so that cancels, leaving us with 4y here. Then is less than or equal to 36. Okay, and then divide both sides by 4. Again, that's a positive 4, so we don't need to worry about flipping anything. And that's going to leave us with just y on this side. And that's going to be less than or equal to positive 9. Okay, so we have two different answers here, but we can easily visualize how they go together if we graph them. Again, graphs are a great way of visualizing answers for these things. Okay, so again, 0 in the middle, negatives on this side, positives on this side. So let's start with this one first. Negative 2 is less than y. So I'm going to say negative 2 is somewhere around here. It is smaller than y, not equal to, just smaller than. So I'm going to use an open circle. And that means that y is going in this direction. Now, before I make an arrow here, I want to figure out what this one looks like. So I'm going to go ahead and graph that as well. 9, I'm going to say, is about right here. And y is less than or equal to it, so I'm going to use a closed dot to show that I can be equal to. And because y is smaller than 9, that means that y is going to be on this side. And so we're going to have, we're going to have a line that extends between these two dots. And so there's our graph. All right. Well, again, we should probably get our interval notation for no other reason than practice. A start point and an end point. Read from left to right. So our start point is going to be here at negative 2, and then it's going to go to the right and end at 9. So again, our start point is negative 2. Our end point is 9. And then we need to say whether we can be equal to these or not. Well, this is an open circle. This doesn't have a line on it. Again, either of those things should tell you that this is not equal to. This one's a closed dot. We've got a line under this one. Either of those things can tell you that this is equal to. And so there's our answer. And again, I will pause for any questions we may have. Okay, I'm not seeing any questions, so I'll move on. Okay, so we have equations, we have inequalities. Here's a new type of equation. So we've talked about this before, but I want to go over it again. Maybe we have something like y squared plus 24y plus 140. Man, that's better. Equals 0. Okay, so this is a quadratic. And again, you can tell it's a quadratic because we have some variable squared. Okay, so if we want to solve this, we have several different methods we could use. We could use AC method. We could use complete the square. There's also another thing called the quadratic formula, but I'm going to use complete the square here, just because I think we could really use the practice. So, first step in completing the square, make sure that your leading coefficient is positive 1. So this number here in front of y squared needs to be positive 1. And hey, we're in luck, it is. If it's not positive 1, remember that what you need to do is divide everything by whatever number is in front of it in order to make this positive 1. Okay, we don't need to worry about doing that, so we can move to the next step. The next step is to get the y's alone, the y's on one side. So we're going to need to take 140 to the other side. Okay, so that'll cancel it out here, just leaving the y's on this side, which is what we want. Okay, and then we are going to take half of this number, the middle number, 24, and then square it and add that to both sides. So half of 24 is 12, and then 12 squared is 144. So we're going to add 144 to both sides. And what that does for us is make a perfect square trinomial on this side. And remember, those are nice because we know exactly how they factor. Okay, so now let's go ahead and combine these, see what we get. So negative 140 plus positive 144 is going to leave us with 4. And so I'm just going to write that down here. Then over here, again, this is a perfect square trinomial now since we added this term, which is half of this squared. And so we know how this factors. It will always factor the same way. Take this variable, write it down. So put a y down there. Take this sign, write it down. So plus goes there. Take half of this number, write it down. So 12 goes there. And then this whole thing is squared, and we now have it factored. Okay, so now we have something that'll be easy to solve. We don't have these like y squareds versus y to the firsts. We just have y. So we can get rid of these parentheses by taking the square root of both sides, and that'll let us get to those numbers on the inside. So take the square root of this side, the square root and the square just cancel, leaving us with y plus 12. And then on this side, square root of 4, remember, is not 2, not negative 2, but both of them, plus or minus 2. And that is very important. Always remember that if you take the square root of an aside, it's going to give you plus or minus that number. All right. So now, to get y by itself, we subtract 12 from both sides. And we get that y equals negative 12 plus or minus 2. So now we actually need to do plus and minus separately. So that means that y, if we do negative 12 plus 2, that's going to be negative 10. So y could be equal to negative 10. And then if we do negative 12 minus 2, that's going to be negative 14. So y could also be negative 14. And there's our two answers. So again, completing the square, the nice thing about it is that sometimes AC method doesn't work because it's not something that we can actually factor. However, completing the square gives us something that we know we can factor. It's not always going to come out to be nice, neat numbers like negative 10 and, oh, sorry, that should be negative 14. Not always going to be nice, neat numbers like negative 10 and negative 14, but it will give us the answer no matter what. Because again, sometimes AC method just doesn't work with these things. It's nice when it does, sometimes it doesn't work. Completing the square will always work. Okay. So let's try another thing. And this will probably be the last example for today. Alright, so sometimes we have things that are higher degree than 2. So this one will have y squared minus 1 quantity squared minus 8 times y squared minus 1 plus 15 equals 0. Oops. Okay. So again, this thing is a higher degree polynomial, and that's because if we were to go ahead and multiply everything out here, we would get y to the fourth, not y to the second, y to the fourth. However, as it is right now, we can actually force this thing to be a quadratic, something with a degree of 2. Okay. So, what I'm saying is that if we look here, y squared minus 1 and y squared minus 1 are both here. And we can simplify this a little bit by replacing those with something. I'm going to say m. So m equals y squared minus 1. So everywhere that we have a y squared minus 1, we're going to just write m instead. So m in for this one, squared, minus 8, m, because we have another y squared minus 1 here, plus 15 equals 0. So now, this is easily recognizable as a quadratic. We have some variable squared. And it's even in standard notation. We have our squared, then our first power, then our zero power. Okay, so again, what we can do here is we can either use AC method or we can use complete the square method. I'm going to go with complete the square method. So again, check and make sure that our leading coefficient is positive 1. It is. So we can move on. Now we want to get our variables by themselves on one side, so we need to get rid of this 15. So subtract 15. Subtract 15. That'll cancel here, leaving us with just the m's, which is what we want. So m squared minus 8m equals negative 15. Then we need to look at this number, take half of it and square it, and add that to both sides. So half of 8 is 4. 4 squared is 16, so we will add 16 to both sides. So this will be m squared minus 8m plus 16 equals, well, negative 15 plus 16 is 1, so I'm just going to go ahead and put 1 there. Okay, now we need to factor this side, and, well, it's a perfect square trinomial because we took half of this, squared it, and add that to both sides. So we can just go ahead and factor this the way we know it goes. M is going to drop down. This sign, negative, is going to drop down. And then 8, half of that is going to drop down. So we're going to drop down a 4. And this thing is squared. Okay. So now we need to open up these parentheses by getting rid of this square. So we do that by taking the square root of both sides. That's going to leave us with just m minus 4 is equal to plus or minus 1. And then take the 4 to the other side by adding it. So m could be equal to, let's see, 4 plus 1 is 5. And 4 minus 1 is 3. So m could be 5 or 3. Now, that's not our answer, though. That's just what we replaced these with. So now we need to go back up here and say, all right, m could be 5 or m could be 3. So y squared minus 1 could be 5. Whoops. And y squared minus 1 could be 3. And we will need to solve both of these cases in order to figure out what y is. Okay, so I'll add 1 to both sides here. That'll give me y squared equals 6. Then take the square root of both sides. That'll give me just y. And on this side, we have plus or minus. Let's try that again. Plus or minus the square root of 6. Same idea here. We're going to add 1 to both sides. So that'll cancel here, leaving us with y squared equals 4. Sorry about that. Then take the square root of both sides. That gives us that y is equal to plus or minus 2. And so we have 4 answers. Again, this started as a degree 4, so we should get 4 answers. That being y could be equal to positive square root of 6, or negative square root of 6, or positive 2, or negative 2. So I will pause for any questions. Yes, I am still here. If you have a question, please let me know. I mean, how did I know that you were going to say that? It finally happened. I can't even be mad. Okay, I'm going to figure that no one has any questions right now. And that'll do it for the stream. He got me right at the end. All right, so again, Mr. Mrozinski's exam is tomorrow. It'll be over the stuff we talked about today and the stuff that was on our review for my exam. So, like I've said before, my exam is the same stuff that you can expect to see on Mr. Mrozinski's exam. And uh, I'm just going to end because I'm getting spammed now. All right. And I'll see y'all later.